What's up, Chem fam? This is Lit Chemistry, where theory meets excitement and concepts spark with clarity. So, today, let's understand one of the most important concepts in organic chemistry, aromaticity. For a molecule to be aromatic, it must satisfy four criteria. Okay, so the four criteria are cyclic, planar, conjugated, and satisfies Huckel rule. This is the main rule here. So these are the criteria, and next coming to the examples. So we are having a benzene ring here. Inside the benzene ring, we can see three bonds. They are called pi bonds. Okay, and each pi bond has two pi electrons. So we have the main formula here is 4 into n plus 2. This is the main formula. As we have three bonds here, 1, 2, and 3. Each bond has 2 pi electrons. So 3, we have 3 bonds now. So 1, 2, 3, 4, and 5, 6. So the answer will be 6. So we can always predict what's the answer by counting the pi bonds or pi electrons from each bond. So answer will be 6 pi electrons. So in order to get the answer as 6, we must substitute 1 in the place of n. So 4 times 1 is 4 plus 2 is 6. So the next structure we have cyclopentadienyl anion. The name is not that required. We are using the same formula here. Here we have two pi bonds and we have a minus sign. So this minus sign acts as two pi bonds here. Always whenever there is a negative sign, it acts as two pi bonds. So it becomes 6 even here. So we have the formula, that is the main Huckel rule formula, 4 into n plus 2. So we know 1, 2, 3, 4, and 5, 6. We are going to get the answer 6 because there are 3 pi bonds as the same as one in the first one. So 4, in the place of n we are inserting 1 plus 2. So the next structure we have is furan, and here there are 1, 2, 3, 4, and these lone pairs act as one pi bond, means two electrons. So here also same, the answer is 6 only. So we have the same formula, we are going to write the same formula, and that is the formula is 4 into n plus 2. This is the Huckel rule formula. So we know the answer is 6 because even the lone pairs add on to a bond. Always whenever you see a lone pair in these type of structures, it contributes or it acts as a bond. Keep it in mind. So 4 into 1 plus 2 is 6 pi electrons. So the fourth example that we have is cyclopropenyl cation. So in this structure there is a pi bond which acts as two pi electrons, and here there is a plus sign. So whenever we see a plus sign, it doesn't contribute towards any bonds, we must ignore it. Only a minus sign or a negative sign contributes towards two electrons. So the answer will be 2. So we have the formula 4 into n plus 2. So here the answer will be 2 pi electrons. So in order to get 2 as the answer, in the place of n we substitute 0. 4 into 0 is 0 plus 2 is 2 pi electrons. So the next subtopic is anti-aromaticity. In anti-aromaticity, we have anti-aromatic compounds. So it has four criterions, same as aromatic. So first one is cyclic, planar, conjugated, and here the fourth one is slightly different, that is contains 4 and pi electrons. Here are a few examples. For the first structure we have is cyclobutadiene. The formula here will be 4n pi. So there are two bonds here. Two bonds means 4 pi electrons will be the answer. 4 pi electrons. So in order to get 4, we put n value as 1. So it becomes 4 pi electrons. The next example that we have is cyclopropenyl anion. So in this structure we can see one pi bond, and there is also a negative sign. A negative sign means another pi bond. So there the answer will be 4 pi electrons. So in the place of n we substitute 1. In the next example, we see two pi bonds and a plus sign, a positive charge. So a positive charge never contributes towards any electrons. So we have two pi bonds, which means four electrons. So in the place of n, we substitute 1. So 4 into 1, that is 4 pi electrons. So the next structure we have is cycloheptatrienyl anion. Here we are having 4 pi bonds. There is a negative charge at the top. It also contributes as 2 pi electrons. So 1 2 3 4 5 6 7 8 8, we get the answer as 8 pi electrons. So in the place of n we insert 2. 4 into 2, that's 4 to 8. We also write the formula 4n pi, that's the formula. So here is a tip. This tip is only for aromatic compounds. Always in aromatic compounds, the results will be either 2, 6, 10 or 14 pi electrons. Mostly, not all the time. And that's it.